Hi, I'm ShunKD, and first of all sorry that I wasn't able to keep up with my schedule. Making YouTube videos is a lot harder than I first thought, and I had to write exams for uni so I wasn't able to make videos. My new schedule is to upload a video on the first Thursday of every month. If you have trouble understanding me, you can turn on the closed captions in the bottom right corner of the video player. Some time ago, a big YouTuber called Thunderf00t made a few videos about him busting the so-called Hyperloop, Elon Musk's idea to enable people to travel long distances in short periods of time, by what essentially is a maglev in a very long vacuum tube. Elon Musk presented it as a great idea in 2013, and now in 2016 they're still on it, but Thunderf00t doesn't think they'll succeed. Now with this video I'm not saying that they'll succeed. I'm not even saying that a Hyperloop is at all feasible. There are still points Thunderf00t makes which probably will make the development of the Hyperloop very hard, if not impossible. The links to his videos are in the top of the video description. He's an awesome YouTuber with great content, but I think he made some mistakes here and I want to point them out. So that being said, let's get started. So what he's going to talk about is what happens if there's a failure of the vacuum tube, and this is quite a big theme in his videos. For this he sets up an experiment in which he places a metal ball inside a glass tube which he pumps the air out. Then he simulates a failure of the Hyperloop, as he calls it, by breaking open the tube at one end. I say the term burst open is more appropriate since a failure can be fairly small, but whatever.
Hyperloop. Now bear in mind this is merely the acceleration that you can get off about 60 centimeters, that's about 2 feet of tube. The acceleration you would be likely to get in the event of tube failure on the real Hyperloop would quite literally be like being shot down a gun barrel.
So, what we've got here, this is going to be our mini 100th scale Hyperloop, and there's a little metal ball in there. So we actually zoom in on the little metal ball. Okay, so there's a little metal ball in my mini Hyperloop.
So this is what it looks like filmed at 1000 frames per second, and as you can see there's really quite a formidable acceleration there. And bear in mind this is a tiny diameter tube over a short distance, about half a meter. If you had a tube failure on a 2 meter diameter tube, as with the Hyperloop, over a significant distance, it would quite literally be like being shot down a gun barrel with no way of stopping.
Okay, so scale 1 to 100. Let's check this. His tube's diameter is about the same as the diameter of the metal ball, which seems to be in the order of magnitude of 1 centimeter. The diameter of the real Hyperloop, of course, would be in the order of magnitude of 1 meter, so that works out. However, we have to consider that not everything scales linearly. Lengths do, and his model works out for that. However, areas scale proportional to the square of length, and volumes proportional to the cube of them. So if this was 2 meters in diameter, that means that there would not only be 200 times the force we see here acting on the metal ball, but 200 squared, so 40,000 times that, which is probably way worse than what most people would expect. But we have to bear in mind that force is mass times acceleration. So acceleration is force divided by mass. And mass scales linearly to volume, which scales to the cube of length. And mass scales linearly to volume, which scales with the cube of length. The small metal ball has about 1 centimeter in diameter, so its radius is about 0.5 centimeters, and if we assume it's made from iron, its density is 7.87 grams per centimeter cubed. So we can calculate its mass by multiplying the density with its volume. The volume of course is just 4/3 times pi times the radius cubed, which gives us a mass of about 4.12 gram. Given that if the vacuum tube of the real Hyperloop bursts, there will be about 40,000 times the force acting on the capsule as we see acting on the metal ball here, This means that there will be an equal acceleration if the capsule has a mass of 164.8 kilograms. However, if we take a look at the Hyperloop Alpha document, link in the doobly-doo, we see that the mass of the capsule is expected to be about 15 tons. And oh, by the way, in your second video about busting the Hyperloop, you mentioned exactly that.
Also has to take the vibrational force of a 15-ton capsule going through it at nearly the speed of sound.
As for the same force, acceleration scales linearly to the inverse of the mass, we can simply get a factor between the acceleration we see in the video and the acceleration that would happen in reality, like this, and can see that in reality there only would be about 1% of the acceleration we see in the video. But yeah.
And bear in mind this is a tiny diameter tube over a short distance, about half a meter. If you had a tube failure on a 2-meter diameter tube, as with the Hyperloop, over a significant distance, it would quite literally be like being shot down a gun barrel with no way of stopping.
And don't think about how the results of the experiment would scale up, and totally neglect that if you only experience 1% of the force you'd assume to experience from that experiment, that might very well have a slight impact in your ability to counteract it. So on to his next video about busting the Hyperloop.
In this video, we'll take a look at the Hyperloop, the brand new method of transport brought forth by the entrepreneur and billionaire Elon Musk.
But it would be for a fifth mode of transports. I have a name for it, which is called the Hyperloop.
The Hyperloop?
Hyperloop, yeah.
The system is proposed to travel at an average speed of 900 kilometers an hour and at a top speed of 1,220 kilometers an hour.
It's very similar to an airplane on high altitudes. You have a low pressure environment inside the tube, a capsule that doesn't touch anywhere, hovers, and then because of the low pressure doesn't encounter a lot of resistance.
It's also a lot faster. You can basically get from downtown LA to downtown San Francisco in 30 minutes. It's also extremely energy efficient due to solar power utilization. In fact, the Hyperloop could generate more power than it consumes as a closed system.
Because you generate more power than you consume in the system.
It's also much cheaper to build. It's about 1/10 the cost of the proposed California high-speed railway system. This means that tickets could cost as little as $25.
1,000 kilometers per hour in a vacuum tube for less than the construction costs of what is currently proposed for the high-speed rail connection. It will generate more power than it uses by solar panels, and a ticket will only cost about $20. Yeah, and it's complete bullshit. Now sure, the principle is fine. It's just not viable in practice. You know, it's like the solar roadways thing. It sounds great, but in reality, it's just bullshit made up by snake oil salesmen. Or the mindlessly optimistic daydreaming of those who just don't want that bitter taste of reality.
Really? I thought it was quite evident from the beginning that a solar roadway was complete bullshit. But that's besides the point.
The first real challenge is simply the near impossible goal of building a 600-kilometer long vacuum chamber. I mean, even in the smaller version of the Hyperloop, which I could only just about stand up in, so it's about 2 meters in diameter, which has a cross-section of about 3 meters squared, and if it's 600 kilometers long, at 600,000 meters long, that means that the volume will be about 2 million cubic meters. So let's compare that to the world's largest vacuum chamber, shall we? Which is about 1/50th of the volume.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space.
Yeah, that's the vacuum chamber that NASA uses to test their spacecraft in, and it's 50 times smaller than the smaller version of the Hyperloop.
Totally different thing. You see, NASA had to build a giant dome with all dimensions being very big. It's very difficult to counteract all of the pressure in this case. You can't just double the volume if you increase the length of all walls a bit, then double it again doing the same thing again. However, the Hyperloop vacuum tube is, well, a tube. It has to work for some length, and then you can just build that part again, attach it to the end of the first one, and you double the volume. Then take everything you got until then, again build it another time, add it to the end, and you double the volume again. And you can do this an arbitrary number of times with no added difficulties. Doubling the volume of the giant NASA vacuum chamber and preserving its shape very soon brings you to the limits of what classical materials are capable of handling. So that comparison is completely worthless.
So the walls are about 2 centimeters thick, about an inch or so. Cool, so we can now do the calculations for just the steel required to make only the tube in this structure. And it turns out to be about the same mass as the steel in the World Trade Center, which, to be fair, was a ginormous building. Cool, so that would get us the steel to make the tube.
And as we all know, it's impossible to gather enough steel to build the World Trade Center. Oh wait, it has been built.
Then comes the first real problem, which is expansion. Most people know that if you just have, say, bridges, you need an expansion joint in them. So let's take a look at the expansion for steel. It's about 13 parts per million per degree Celsius. So let's say the temperature range is going to be between freezing point and 40 degrees Celsius. That's basically a hot day, which means the overall length of this tube is going to vary by about 500 parts per million, that sort of thing. Which means that the overall length of the Hyperloop from the coldest day to the hottest day will vary by about 300 meters, about the length of 3 football fields. Clearly, expansion joints are necessary. Well, that would be easier if you're looking at the expansion joints on a bridge. Not so much if they're an expansion joint for a vacuum tube, because it's got to hold that vacuum almost perfectly whilst it's changing its length. So let's give them something reasonable, like a 100-meter segment of tubing. So the expansion difference between say a hot day and a cold day there would be about 50 millimeters, so a couple of inches. So you would need a joint about every 1/10 of a kilometer, such that in the 600-kilometer Hyperloop, you would need about 6,000 moving part vacuum seals.
That doesn't mean it's impossible. It just makes it more prone to failing. And that's only if your assumptions hold true, which they don't. Please just read a tiny bit of text we just showed and compare it to what you just said. The first paragraph merely talks about ground-based high-speed rail systems. The Hyperloop isn't ground-based, so forget about it. The second paragraph tells us exactly that, and furthermore tells us that the Hyperloop vacuum tube is planned to be built on pylons and will not be rigidly fixed at any point, therefore eliminating the need for expansion joints. So you don't need all those moving parts you just made up. The part you highlighted merely talks about the end stations. That's 2 moving parts. I think that they can handle 2 moving vacuum seals, which isn't exactly close to the 6,000 moving vacuum seals you just made up, or 60,000.
And this is, of course, assuming 100-meter segments of tubing. Their current segments look to be more like 10 meters or so, which would mean they would need 60,000 moving part vacuum seals on a 2-meter diameter tube.
What? Why would you put in a moving vacuum seal for every single segment? Do you know that steel tubes can be welded together without the need for moving vacuum seals?
I mean, the only thing even remotely comparable in the world is the Large Hadron Collider, which is, I don't know, maybe 50 kilometers or so of tubing, albeit underground, so they're more or less a constant temperature, so they really don't have these expansion problems. And even at that, it's 1/100th of the volume of the Hyperloop.
Volume doesn't matter at all. Length is important because expansion in length is proportional to the length of the tube, not its volume.
And it doesn't have a 15-ton capsule going through it.
Yeah, It only has bundle of protons going 99.999991% the speed of light in it, carrying the kinetic energy of a British aircraft carrier going 22 kilometers per hour. The Hyperloop capsule, with its 15 tons going 1,220 kilometers per hour tops, has at most 42% of the kinetic energy of one LHC beam. But boy are we lucky that a comparison doesn't make sense anyways. To be fair, he talks about how the top of the tube expands more than the bottom of the tube if sun shines onto it from above, and how they're planned to only have expansion joints at the ends, not for every segment, therefore can work in his opinion. Which is actually a valid concern. What should be considered though is that you can mitigate this quite a bit by painting the tube darker on the bottom and brighter on the top, so that less solar radiation is absorbed on the top than on the bottom, and the tube expands more uniformly, therefore lowering the stress on the material and the difference in expansion on the top compared to the expansion on the bottom. It should also be considered that steel is a good heat conductor and that the tube heating up literally happens over the course of several hours. But that's of course not the best solution. There are better ones, like for example eliminating direct solar radiation onto the vacuum tube altogether. This can simply be done by building a cheap, narrow shell around it. The outer shell, which is exposed to the sun, doesn't have to withstand the pressure between the pretty much vacuum inside the tube and normal atmospheric pressure outside the tube. It just protects the vacuum tube. But no, let's talk about how 60,000 moving vacuum seals are needed if you go totally mad and want to build one between every two adjacent segments.
So you would need a joint about every 1/10 of a kilometer, such that in the 600 kilometer Hyperloop you would need about 6,000 moving part vacuum seals, and a failure on any one of them could be disastrous for the people inside the Hyperloop. And this is of course assuming 100 meter segments of tubing. Their current segments look to be more like 10 meters or so, which would mean they would need 60,000 moving part vacuum seals on a 2 meter diameter tube.
And then he drops this.
Planes, of course, cost a lot of money, but they're fairly easy defensible vehicles. Now, when they're near to the ground, of course, they can be shot at. But once in the air, they very quickly go beyond the range of all but the high-end military weapons. That's something that's simply not the case with the Hyperloop. It's 600 kilometers long, and it runs down the middle of a freeway. It's indefensible. Any crazy with an anti-material rifle could shoot holes in the tube, something which would probably be fatal to almost the whole system.
So you can just shoot holes into the tube. According to the Hyperloop Alpha document, the tube will be made from steel, and its walls will be about an inch thick, about 25 millimeters. Matt from Demolition Ranch made a video in which he shoots a 1-inch steel plate with a variety of guns.
I have a cool video plan. This is a 1-inch thick AR-550 steel plate. That's some hard stuff, and it's super thick.
The most amount of damage he made was here.
Did you know they make armor-piercing 50 BMG? See that black tip? That's crazy, right? Oh my gosh. So deep. That thing is probably 3/4 of the way through. We bulged the back side of this with that AP round. Insane. You can see where the paint started chipping off it because it got hit so hard.
Linked to his video, of course, in the doobly-doo. You don't just shoot through that much steel. If you do it with a small projectile going at an insane speed, and hope that you somehow shoot a hole of about 1 square centimeter into it. You don't just rupture the tube by shooting at it. If you break through it, that means that air will rush in at about the speed of sound, if we don't account for friction slowing it down. That's about 340 meters per second, which means that per second about 0.034 cubic meters of air at atmospheric pressure will rush in. Now for a 1 kilometer long 2 meter diameter tube, this means that after 1 minute there is about 0.03% of normal pressure in the tube, about 2% after an hour. And remember, this is only for a 1 kilometer long tube. The Hyperloop tube is way longer than that and won't hold the vacuum perfectly anyways. Vacuum pumps are needed and they can easily make up for such a small amount of air rushing in until the hole is plugged, even with many holes like that. Plus, we're talking about some serious disruptive activity here, about bringing a very strong rifle to the Hyperloop and deliberately shooting at it. No one seems to be concerned about people disrupting other ways of transportation with such criminal energy, except for air travel, of course, where you can't even bring a bottle of water with you. It would be much easier to buy some thermite off eBay for a couple of bucks and literally melt down train tracks. You don't need a big rifle and a gun license or an illegal gun for that, and you don't need to carry the gun back home when the police probably is already searching for you because it's easy to find out when a hole has been shot into the vacuum tube, or leave a gun registered with your name lying around. No one will find out that you melted a piece of normal train track until the next train arrives there, and until then you can be long gone.
Practically, what this means is you'll probably need as much security for Hyperloop travel as you would for air travel.
It's also a lot faster. You can basically get from downtown LA to downtown San Francisco in 30 minutes.
Which in reality means there will probably be no more time advantages for using the Hyperloop over flying.
Bullshit. A plane carries hundreds of people and the schedules are fixed in advance. That's not only because people plan, or rather have to plan, their flights weeks or even months in advance, but also because airports are at capacity pretty much all the time, and flights have to be coordinated between different companies and authorities. The airline can't just say, "Oh, we got our plane full already, so we leave early." Especially because there are so many people who want to be precisely on that flight. Furthermore, there are other factors at play, like for example that you have to wait until the turbulences one plane caused when landing or taking off are gone before the next plane can land or take off. You don't have these issues with the Hyperloop, because you have to be on the plane at the right time, and going through security can sometimes take way longer than other times. You always have to plan for the worst case. So you need to arrive at the airport very early, go through security, and after that probably have a long time left which you sit around not traveling. The Hyperloop, on the other hand, is planned to carry only 28 people and to be able to depart every 30 seconds. You probably don't have to buy tickets weeks in advance or hope that you still get tickets if you buy them late. With the ability to depart every 30 seconds, they can sell tickets to people when they arrive and figuratively already stand in the Hyperloop with one foot. The Hyperloop can depart every time a capsule gets full. So even if there will be a shit ton of security, and we all know that airport security is ridiculous, its consequences are by no means as bad as with air travel. You arrive there, buy your ticket, go through security which probably will go fast, and in most cases you'll step right into the Hyperloop and depart within seconds or minutes, not within hours. If something goes wrong when you go through security, you don't have to worry about missing your flight or Hyperloop capsule, because you're not assigned to one. They depart as soon as possible anyways. If you miss one, the repercussions of that are pretty much as bad as arriving at a traffic light when it just turned red. And that's it. Putting that on a level with the hassle of airport security, is just ridiculous.